Hello friends, and welcome to a lecture on operation research. Today we will look into sensitivity analysis. I am Professor Arvind Prasad. Well, what is sensitivity analysis? Pardon my slip of tongue. It is post-optimality analysis. You solve a problem using linear programming methods or the simplex method, popularly known as, and you get the results. Now you start analyzing the results for its optimality and the effect of other conditions on the optimal solutions. That is known as post-optimality analysis. Let's take up a problem to further understand this. You have an objective function. The idea is to maximize this objective function. The objective function is on your screen. It's 50x1 plus 60x2 plus 55x3. Now remember, x1, x2, x3 are variables, yes, but they can also be termed as activities. Subject to the constraints are on your screen. For the first equation, x1 plus x2 plus x3 less than equal to 100. So the first equation, the sum of the value of x1 and x2 and x3 should be less than equal to 100, or the sum of the variables should be less than equal to 100, or I'll repeat it, that the sum of the activities should be less than equal to 100. Well, the second, third and fourth equations, they are pretty self-explanatory. Now we need to understand here that the RHS of these constraints, they are known as resources. So what is linear programming? Now linear programming is about matching level, that is the value of the activities, to resources without breaking limits. So let's get ahead and solve a problem and check what is sensitivity analysis. Well, I have already set up the problem in Excel and I will solve it. If you want to learn how to set up the problem and solve it in Excel, you can refer to my videos in the playlist or to one particular video, the link for which is given below and of course on the right top also. So let's get ahead with solving it. I go to solver. I select my variables. The constraints have been already entered. I just check whether the objective has been set properly or not, and I click solve. Now I select for the sensitivity report and click OK. Let me zoom it up so that you can see the solution. There we are. Now I'll copy this sheet to explain you the sensitivity analysis. So there we are. We have the sensitivity report. Now let me zoom this too. Now it has two parts. One is the variable cell and one is the constraints. Now in the variable cells, it says that the final value is 0, 70 and 30, which indeed is the solution. As you can see, that is 0, 70 and 30. Now let's come to 70 and 30. In the following column, that is under reduced cost, you find 0 and 0. Well, what does this mean? It means that 70 and 30 are the optimal values. Now let's come to the first one, that is 0. It says that the reduced cost is minus 7.5. Now let's demonstrate what is the meaning of this. Let's go back and let's increase the value of x1 by 1. Well, as you can see, the constraints are not met. So let's go to solver. Let's go and select x2 and x3 and click solve. Now, as you can see here, all the constraints have been met and we have arrived at a new solution. But what do we find here? that the value of the maxima has gone down by 7.5. Coming back to the sensitivity report, this is what reduced cost minus 7.5 means. That though it is not an optimal solution, but if you change it, you are likely to make the case worse. That is, you are likely to reduce the profits. Now coming to the objective coefficients, 50, 60 and 55. The allowable increase and decrease to these coefficients are given in the following columns. What it means to say? It just means to say that if you increase the objective coefficients within the allowable increase or decrease, your optimal solution will not change. Let's demonstrate this too. The allowable increase for first coefficient, that is the coefficient of x1, is 7.5. So let's go back. Let's keep this to 0. And let's make this as 52. Now let's go to the solver and select all the three variables and click solve and click OK. As you can see here, we get back to 0, 70 and 30, which was our original optimal solution. Though we have changed the coefficient from 50 to 52, the optimal solution has not changed. A similar logic goes with allowable decrease. 1 e raised to 30 means infinity in Excel. So the allowable increase for 50 is from 50 to 57.5 to 52 on the other side, infinity, minus infinity. That is, I can decrease it to minus infinity. For coefficient of x2, it is infinity and 5. So it means it can be either infinity, the range is between infinity and 55, where of course 70 will be the optimal solution. And the similar explanation goes for the final coefficient, that is 30. Now let's get to the constraints. Now in the constraints, as you can see here, we have the value of the constraints, that is the final value of the constraints, which is 270, 60, 100 and 270. Okay. Now let me do something here. Let me create a few columns here and drag them to put them in order. So you have E9, E10, E11 and insert one more, drag and take E8 also. Now this corresponds to B1, B2, B3 and B4. There we are. So the final value is 100, 270, 270 and 60. Now the following column is that of shadow prices. Now what does this mean? Let's go and understand this. So for B1, the shadow price is 60. Now come to B1 and increase this to 101. Now go to the solver and again click solve. As you can see here, the profit has gone up by 60. So what does this mean? All this means is that if you increase B1 by 1 unit, the profit goes up by 60. Coming to B4, what it means is that if you increase B4 by 1 unit, the profit will go down by 2.5. And about B2 and B3, it says that the shadow price is 0. What does it mean? That even if you change it, the profit is not going to get affected. Now, why is this so? Remember one thing, the final value of these constraints are lesser than the limits placed. That is, in the first case, B2 is less than 300, and in the second case, B3 is far more greater than 250. Right? So here in this case, that is in the case of B2, even if I increase it from 300 to 301, it is not going to affect the profitability because the solution will converge to 0, 70 and 30. Similarly, in the case of B3, even if I increase from 250 to 251, the solution will converge to 0, 70 and 30. And therefore, the profit will be 5,850. Now, finally, the allowable increase and allowable decrease. All it says is, what is the allowable increase and decrease for B1, B2, B3 and B4? If you change the values of B1, B2, B3 and B4 beyond these allowable increase and decrease, the optimal solution will change. So that is it. Thanks for bearing. It was a rather long video. If you like the video, do like and subscribe my channel. And do share this video with your friends. And do give me comments and feedback so that I can make more such videos for you, and at least I can get an idea of what needs to be done. Goodbye, friends. Good evening.